This is Avin.
So I looked up the law of sines proof because I wanted to know the law of sines proof because I like to know proofs of stuff. And so first, to demonstrate that it works on all triangles, we're going to draw the most purposely dumb, non-specific triangle you could possibly imagine. So something like that, give or take. Nothing special about this. That's not a right angle and nothing isosceles. Nothing weird like that. And we're just going to give some abstract angles here. Like here's an angle A, here's an angle B. And for simplicity's sake, side little a and side little b. And let's give this a height of x. And how you get to the law of sines is, well, how do you find x? Let's see, so the sine of angle A is equal to opposite hypotenuse x over b. And so you multiply both sides by b and you get x, which is b times the sine of A. Simple enough, right? But that's not the only way to get to x, is it? No, you can do it from the b perspective too. Sine of b is equal to opposite over hypotenuse, x over A times sine b equals x. Now look what we got here. We have two separate things that equal x. And by a certain law of math that you should have learned in elementary school, I don't mean to be that condescending.
Elementary.
Elementary, my dear. I can't think of a Watson pun off the top of my head. But that means b times the sine of A is equal to A times the sine of B. And it's very simple to get to the law of sines from here. First we divide by b and we get sine A equals A sine B divided by side B, and then we pointed that way?
Oh yeah, look at you.
Okay. And then we divide by A, and finally we get sine A divided by A equals sine B over B. Let's make that look less like a exaggerated B. And since I chose these angles and sides completely arbitrarily, we can throw in a C here too, because it would make absolutely no difference whatsoever, and thus we have the law of sines.
Nice.
I have one very small addendum. Can anybody guess what it is?
Maybe?
This is an extremely small complaint. I know you meant to say this. So,
Where you put the height matters?
yeah, so where you put this angle, or this kind of X side, right? You dropped that thing in there.
Mm-hmm.
So what was important about that dropped side?
That is the hypotenuse of the angles.
Close.
Or the opposite of the hypotenuse.
Yeah, so it needs to, one, hit this corner, and two, be perpendicular to the bottom. You guys see that? That's what's allowing Avin to play the sine game here, right? Is that those were perpendicular. Cool? Otherwise, perfect. Very cool.